will proceed in pseudo calculus problems. Okay, we are proceeding example by example, but again we are in the perimeter of circle or area of circle. But anyway, we have brought in a new fundamental into calculus that is called repeated summation. If I have repeated summation, then can we convert into integral calculus? Okay, this is the scenario that we are proceeding into. Repeated summation. Repeated summation can be in two forms. One is called discrete, discrete or digital, someone can say discrete value, different value. And one is called continuous value, or someone can say analogous, analog, analog, that is continuous, and one is discrete, that is different. Consider that a kind of there are students in the class. Consider there are students in the class, and each student they are securing marks out of 100. They are securing marks of out of 100, and there are 30 students in the class. There are 30 students in the class, and they have secured marks out of 100, out of which 5 students they got 50 marks. Okay, 3 students they got 60 marks. 2 students they got 40 marks. Okay, there are 30 students. I am telling about 10 students. Others they got other marks. Now this is x-axis, that is called marks. I'm sorry, this is x-axis, that is called marks, and this is y-axis, that is called number of students. I believe it is all right. What I am saying is all right. Okay, so this is the scenario. The students they have secured marks, and 5 students they have secured 50 marks, and 3 students they have secured 60 marks. 2 students they have secured 40 marks. If I draw a chart, if I draw a graph, x-axis is marks and y-axis is number of students. Okay, then now I have to count very thing. Now if I just mark it, 1 mark, 2 mark, 3 mark, 4 mark, 5 mark, 6 mark, 7 mark, 8 mark, 9 mark, 10 mark, like that. So I have 100 cuts on x-axis, where each cut is spaced by 1 mark. Makes sense? And in y-axis, I have number of students. Now at 50, at point 50, I have height as 5. Now at 60, okay, I have height, there can be mark as 51, 52 also. I have height of 3. At 40, I have height of 2. Now, if I'm trying to calculate how many students are there, if I'm trying to calculate how many students are there, how I can calculate? That is the question mark now. At marks 50, I have 5 students. At marks 40, I have 2 students. At marks of 60, I have 3 students. What I'll do is I'm going to add all the verticals. Okay, so now I can say I equal to 0 to I equal to 100, I equal to 1, means no one has secured 0 mark. I equal to 1 to I equal to 100. Now it is fx at any x. What is the height? That is the fx. Just add fxi, function over xi, function over xi. If I add from 1 to 100, then it will give the net number of students in the class. Okay, that is one scenario. Another scenario is, what is the average mark students are getting? What is the average mark student have got? Okay, I'm not going to talk more on it, but I can give a kind of a a precursor or something like that, a trailer that is that is something teaser that will be the next discussion, probably next day or something like that. How many students are there in the class? If I'm asking that question, how many students are there in the class? Then if I talk about 6 at 50 marks, I have 5 students. Now at 50 marks, I have 5 students. How many? First question was how many students are there in the class? Next question is what is the average mark of the student in the class? Average marks of the student in the class. At 50, we have 5 students. At 60, we have 3 students. At 40, I have 2 students. What is the average mark that is secured by a student in the class? This is the another question. Now, rather than going by the chart, someone can write it down. There are 30 students only, right? Okay, there are 30 students. Now, student by student, write the in a kind of in a vertical manner, student by student, write the number. One student have got 32, one student have got 92, one student have got 52, one student have got 50, one student have got again 50, one student have got 60, one student have got 40, one student have again got 60, like that 30. Someone will write. Now whatever the marks has come, divide by 30. That is the average mark. Okay. Now there is another way to it. What is another way? Another way is whatever the height we have, at 50 we have height of 5. At 50 we have height of 5. Height is called function over x. If this is x axis, that is the marks, and y axis is the how many students are there, then height is, we call it function over x. Consider like that. In that fashion, if I take the 50 bar, then I have 5 into 50. That is another way of saying like this. 5 into 50 plus 4 into 60 plus, I'm sorry, 3 into 60 plus 2 into 40, like that. Height into the distance from the origin. Okay, that also gives the how much marks that is calculated. Now add everything, divide it by the n, that is 30 students we are talking. What it is now? At any distance x, what is the height? Up. Okay, if I'm talking about average mark, if I'm talking about how much how much are the marks that are calculated by the student, how much marks get calculated by the student. Okay, someone would say that just calculate the mark, or someone would say it is x into fx. Up. Now summation, summation of the summation of the I, summation of the I, that is I equal to 1 to 100, x into fx. Up. X into fx. X is distance from origin and fx is the height. Like for 50 distance, I have 5. 5 into 50, that is for that. Now, if I break it, summation of I equal to 1 to 100, and then xi fxi. If I do like this, it becomes x1 fx1 plus x2 fx2 plus x3 fx3. Like that, x 100, because someone can get 100 also. X 100 fx 100. If someone add it, then it will become a kind of net. It will become the full 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 number. Okay, divide by number of the students, it will give the average score made by the student. Okay, now question is arising, can I, if fx is function over x and that is really a some function like normal distribution called Gaussian distribution. If I talk about normal distribution, I believe the formula is okay, that we will see. Anyway, how I can, how can I represent this summation I equal to 1 to 100 x xi fxi into integral calculus? Right now we cannot do. Okay, why we cannot do? Because it is discrete. It is point by point. It is not smooth. If it is smooth, then we can do. But still we can do. How we can do? Why we cannot do? Because it is digital. It is discrete. 1, 2, 3, 4, 5, 6, 7. If it is completely a continuous curve, then we can transform into integration. What is transformation into integration? If I transform any graph into integration, indirectly we are trying to calculate area of the graph. We are trying to calculate area of the graph. What is integration? Integration is nothing but calculating the multiplication of width and height through the graph. What is through the graph? Through the area. If x-axis represents number, the marks that students have secured, and y-axis represents the how many students are there in that particular marks. If that is the case, if I draw a graph, continuous graph, and if I calculate the area, that is called integration calculus. That is fx dx. If I calculate fx dx, if I calculate fx dx, what it will give? Consider this is homogeneous graph, means this is a continuous graph where height talks about number of students. Height talks about number of students, whereas span talks about in what span the number of students are. Okay, in that fashion, if I take full span and multiply by number of students, then it will give total number of students. The area will give total number of students. I believe it is all right. Or I can just calculate fx, summation fx, that will also give total number of students only. What is difference between discrete heights, that at 60 marks I have 5 students, at at 60 marks I have 3 students, at 50 marks I have 5 students, at 40 marks I have 2 students. This is what we are talking. So the students count is there, but it is discrete depending upon the marks. If I make a continuous line, what is difference between this continuous line when line height talks about the number of students, where the base talk about at what mark number of students are there. Consider number of the marks has been granted only integer fashion only. Student is getting either 1, 2, 3, 4, 5, 6, 7, 8 marks, not 1.1 or 5.5 or 28.8, only integer fashion. If it is integer fashion, then it is discrete value. Otherwise, if it is any marks student is getting, then it will be kind of continuous variable. I am not going to discuss much about it. But if I add all the verticals, if I add all the verticals, then it gives me the net students. If I multiply vertical with the origin distance and then sum all, that is xi fxi, it gives the total mark. Divide by the student, it will give the total student. Consider this is discrete. This is discrete. How I can use integration over it? Now there are two things we are talking. One is called discrete values and one is continuous value. If I talk discrete value, then in one marks range I have one height. In one marks range I have one height. In one marks range I have one height. Means I can say that between 60 to 61, between 60 to 61, excluding 61, including 60, I have one bar. 61 to 62, excluding 62, including 61, I have one bar. Okay, if I multiply height into width, height into width, height into width, what is width? Width is only 1. Okay, in that fashion, we can transform it into summation. Every session we give this exam, this theory. We transform I equal to 1 to 100 fxi, fxi into 1, because for 1, because all marks that is obtained in number only, there is no fractional marks. In that fashion, it becomes I equal to 1 to 100, and then I equal to 1 to 100, and then fxi into 1, because one height belongs to width is 1, one person. If someone is getting one, then if I draw the graph, it will be one thickness and it will go as how many students are there in the one marks category. For God's sake, no one should secure one, but this is how it is. So I can write as full number of students in the class, just number of students in the class. Summation of I equal to 1 to 100 fxi, function over xi, and then delta xi, where delta x is 1, that is for every fxi. Now this form can be can be, now we have fxi delta xi. It can be roughly trans it can be roughly transitioned into integral calculus. Integration of x equal to 0, x equal to 1 to 100 fxi dx, fx dx. Okay, here fx, that is the height, is called density function. If it is a discrete value, it is called mass function. More or less they are similar only. Okay, if I have a continuous graph against x axis where height is continuous, then this height is called density function. Density function, in the sense, consider that I have a marks of a student between 50 to 60. Okay, I'm drawing a graph between 50 and 60. 50 and 60. The height is constant 4. Okay, I'm sorry. Height is constant 22. Between 50 and 60. Height is constant 2. Now I can draw a smooth graph between 50 and 60. That height is a smooth 2. What is 2 now? Any point, if I say it is 2, it is 2. This is continuous line now. This is called density function. Density between 50 and 60 is 2. If you multiply this density with the horizontal, you will get the net amount, that is 2 into 10, 20 students are there. This is called density function. Density function means students per unit, how many they are. Okay, so if I draw a continuous line, if I draw at 50, I have 5 students. 55, I have so many. I have 60. This is discrete value which has width of 1. Discrete value which has width of 1. It may be discontinuous, it may not be continuous. But if I say between 50 and 60, between 50 and 60, there is a graph like this. There is a graph like this that is continuous. Okay, in that sense, continuous, how you nomenclate, how you give nomenclature to the continuous function. Continuous function is called density function. If I have a continuous function from 50 to 60, and then area underneath this continuous function is, it may not be a flat line. If it is a flat line, then flat line height into width, if I multiply, that is 2 into 10, then there are 20 students in that range. If it is not if it is not a flat line, also if it is a graph like this, then I have to integrate it to get the number of students. That will be fx dx. X is from 50 to 60. Fx can vary. This is difference between analogous and discrete. This is why I brought this into the point, is book are misleading the people. I have even seen very good books also. They are misleading the people, claiming discrete is different to the analogous. Discrete is not different to the analogous. Discrete is bound to one, discrete typically it is bound to one width, whereas analogous is bound to bigger width. But at the end, discrete also you calculate the area only, where hidden is 1 is hidden. If I say at 50, number of students is 5, not true. Actually, between 50 and 51, excluding 51, in width of one number of students is 5. That is a area, not a line. That is the difference. Anyway, means analogous and discrete, more or it is less it is same. If it comes to analogous, it comes to continuous, then for full range I have some value. To get the actual number of results, you have to integrate. Whereas if it is discrete, you can just add it. You can integrate also, but width will be always 1 for everyone. Anyway, we will talk more on it. Why we will talk more on it is, consider one example, or people can think about it. Consider this is of length 1. This is of length 1. This length is 1 meter. Hope I don't know it is 1 meter or not, but consider it is 1 meter. Now I am breaking it. I broke it from here. If I break it here, then it comes in two parts. One part is this and one part is this. Now I take the longer part. Again, I break it from some point. Consider I break it from here. Then it is in two parts. I take again longer part, but longer part can be on right hand side also. It can be left hand side also. Depends upon where I am cutting. If I cut at the exactly at the middle, any side I can take. Otherwise, if I cut right side, the left I have to take. If I cut left side, right side I have to take. I have to take the longer part in a stick which has length 1. Now tell me, if I collect all the longer part, I made a 1000 attempt. If I connect all the longer part, then what is the average width of the longer part? Okay, that is the question. Question is, if I have a stick and that is 0 to 1, which it has length of 1 unit, and then I cut into two parts. Okay, once I cut it and then I take the longer part. Okay, I stick it again. Then I cut again and then I see which one is longer part. Okay, I measure the length of the longer part and then I stick it again. Okay, or I have 1000 stick like this which has a length of 1 meter or 1 unit. I cut it and longer part I throw in one direction. I cut it, longer part I throw in another. Cut can be anywhere. Now 1000 sticks I have with the all longer part. If I calculate the length of the stick, all the longer, then calculate the mean of it or average of it, how much it will come. That is the question. Anyway, we will proceed in the perimeter of a circle that we are computing. And perimeter of a circle that we have seen right now can be computed through many ways. One way to calculate the perimeter of a circle is, there is one way that what we have tried is the summation. Summation to calculate the perimeter of a circle, we divide the arc. This is the arc of the circle, complete. We divide the arc into many parts. Arc into many parts. Okay, for one part, I calculate the arc length and then I add, okay, or someone can say, I calculate the arc, I divide into n part. This is first part, this is x-axis. This is x-axis, this is y-axis. This is the first part, second part, third part, fourth part. Like that, I divide into n part. Now each part, if I calculate the length and then keep adding it, all n part, I'll get the perimeter. Okay, in that fashion, we saw two ways. Which I am sorry. Okay, we started with the discussion and then we found that okay, I can take this. There are other ways also available in the book. The most promising way is take any ith part. This is first part, second part, third part, ith part. Take any ith part. If you take any ith part, then this part if you take, then this is the, if I take, consider I take this part. This is x2, y2. This is x-axis. This point is x2, y2. This point is x1, y1. How much is the distance between x1 and x2 in x direction? Consider it is delta x. What is the distance between y1 and y2? Consider it is delta y. So this is delta x and delta y. Now consider this point, ith part, ith section we are talking. This part and this part. This radius and this radius. Radius may not be the same here and here. Radius may vary with the angle. What is angle is, this is x-axis and radius is moving in an angular manner, where this angle what it is making, its angle is theta. So this is radius standing at x-axis, radius started moving. Angle theta is growing now. Angle theta became 90 degree, 180 degree, 270 degree and 360 degree back. Now in that fashion, this is the first section it made for the arc. Second section for the arc. This is the ith section. where the angle movement here considered is delta theta I. That means it moved. Now, if I see the arc along x-axis, it moved delta xi, and in y-axis, it moved delta yi, delta xi, and this is the arc. Arc came as a triangle hypotenuse. If delta y is vertical side of a triangle and delta xi is horizontal side of a triangle, arc came as a hypotenuse of the triangle, though it is not a straight line. If I make delta theta angle that makes the arc, there are three variables here. One variable is delta theta I. Because of that, we are getting the arc. Now, there are another variable because arc is moving like this, radius is moving like this. Along x-axis, x is moving. Along y-axis, y is moving. And along theta axis, if you see the polar coordinate system, theta is the axis. So theta axis is also moving. Now, if along x-axis delta xi move, along y-axis delta yi move, then what is the arc? In this triangle, arc looks like a hypotenuse. If this delta theta is very small, this arc will behave like a straight line, and that straight line length will be delta x square plus delta y square root. This is the ith section arc length. For full section, I will say I equal to 1 to n, because n times we have divided. Square root of delta x I whole square plus delta y I whole square. Okay, then we saw that a square root of delta xi whole square plus delta y whole square, I is a summation, I equal to 1 to n. All delta x, if I take arc by arc, section by section, all delta x are non-overlapping to each other. In that fashion, I can convert into integral calculus where delta x will become dx and delta y will become dy. Now it will become integration of theta, integration of I, we are saying 1 to 100. I'm sorry, 1 to n. That means I section we divided. Now this integration I'm sorry, not theta, dx and dy. Just write integration sign, and then dx whole square plus dy whole square root will give the perimeter. Then we saw dx whole square plus dy whole square is a square root is nothing but it is a magnitude of one vector, that is dxi plus dyj. Dxi vector plus dyj vector. If I calculate magnitude of this vector, it is exactly a square root of dx whole square plus dy whole square. So magnitude, that is the absolute value of a vector, that is dxi plus dyj, integration is the net circumference from where to where we came. And then dxi plus dyj is nothing but derivative of, in bracket, xi plus yj, that is exactly will become dxi plus dyj. Derivative of position vector, magnitude, and then integrative, that will give the circumference. What is position vector is, if this is origin and this is the point, this point is x comma y, this is xi plus yj. Or if I am drawing a circle, like, there can be chance where radius is function over theta. There is a chance that radius is function over theta. If radius is function over theta, if radius is function over theta and r equal to cos theta, then this is the origin. This point is the origin. If this is the origin, this is y-axis and this is x-axis, we will get circle like this if r equal to cos theta. This is what we have seen. This is r equal to cos theta, where origin is here, not here, here. In that fashion also, we can see that our the perimeter works well when it is the magnitude of d of position vector, integration and magnitude of derivative of position vector. Okay, now the question is arising, what is the length of ith section? The length of ith section, we said, and it is delta xi whole square plus delta y whole square root. This is one form of saying the length of the ith section. What is this length of the ith section if I talk about in theta fashion? If I talk in theta fashion and r fashion, in Cartesian coordinate system, length of ith section is delta xi whole square plus delta yi ith section. whole square root. If I talk in polar coordinate system, then what it would be? If I talk in polar coordinate system, then if I go along, then it is integration over magnitude of d of p, where p is position vector. What is position vector? Xi plus yj. What is x? X is r cos theta I plus r sin theta j. What is derivative of it? Okay, if I talk about derivative of it, then I can rewrite d of p, d of position vector, that is d of xi plus yj, or dxi plus dyj. D of p can be written as d of p by d theta into d theta. Okay, normal mathematics. Anything can be written as same multiplication, same division. D of p can be written as dp by d theta into d theta. Now, magnitude of dp by d theta into d theta, this I can take out. This is another form of calculating the circumference, where p is xi plus yj. If I say x is r cos theta, Cartesian to polar, and y is r sin theta, it becomes d of r cos theta I plus r sin theta j by dp and by d theta. Then it will become r is a function of theta. R is not constant. In that fashion, means if consider this is origin, then if I move the angle, then r will start changing because r is a function over theta. In that fashion, dp by d theta will become d of r cos theta by d theta I plus d of r sin theta by d theta of j. That will become dr by d theta, dr by d theta, dr by d theta. I'm sorry, it will become r into d cos theta by d theta plus cos theta dr by d theta, product rule, because both are theta now, I vector, plus r d sin theta by d theta plus d plus sin theta dr by d theta j. Okay, if someone settle down, it will become dr by d theta, dr by d theta, I vector plus r j vector. I think so. Okay, I can try. R d cos theta by d theta, r sin theta minus sin theta plus cos theta dr by d theta, that is I vector. Now I have to do a square of it, and this side j vector square of it, because at the end I am calculating magnitude of it. So what will be the square of it? That is r minus sin theta, r minus sin theta plus cos theta dr by d theta. Okay, square of it, r square sin square theta plus dr by d theta sin theta whole square. I'm sorry, cos theta. I'm sorry. The first will become r sin theta whole square, r square sin square theta. Means the net will be r minus sin theta, r d cos theta by d theta, r minus sin theta, r minus sin theta plus cos theta dr by d theta I plus that side it will be r cos theta plus sin theta dr by d theta j. This whole square root will be the net circumference, and then d theta. Okay, if someone compute it, typically it will come as a square root of dr by d theta whole square plus r square. If someone settle it down, whatever we have written, someone has to settle down. R square cos square theta plus sin square dr by d theta whole square. Okay, minus 2r sin theta cos theta dr by d theta, that will come here. That side it will become r square cos square theta plus sin square theta dr by d theta whole square plus 2 sin theta cos theta dr by d theta minus plus that will completely go away. Now it will become r square cos square theta plus r square sin square theta plus cos square theta dr by d theta whole square plus same thing we will get in other term. Then it will become r square plus dr by d theta whole square root. Now the circumference will become square root dr by d theta whole square plus r square, square root d theta. This is the expression integration. Now we have r is function of theta. Then dr by d theta will come as theta only. Now everything is in theta, d theta. D theta means delta theta. Delta theta I integration will transform into summation. Now it will become I equal to 1 to n. Reverse fashion we are doing. The question is arising? What is the arc length? What is the arc length of the ith section in term of I? This is a very big thing I am talking, and it is available in the book. Means someone can this explanation is not available in the book. How I can get the actual? We talked about approximation. If I remember, we talked about the approximation. What is the arc length when we have ith section arc length? Ith section arc length when we talked in delta xi and delta yi, and this arc we took as a straight line considering delta theta I is very small. In that fashion, it will behave like a straight line. And then we said that arc length is delta xi whole square plus delta yi whole square root. This is the arc length. Base plus height, square root will be this height. Okay, but what is exactly the arc length in terms of delta theta I? If we talk about that fashion, then it will be, if I talk the full parameter, then it will be integration sign and then magnitude of a vector, magnitude, then it will be magnitude of a vector. That vector is xi plus yj, derivative of xi plus yj. If we settle down and calculated the magnitude, it came as a square root of dr by d theta whole square plus r square d theta. Now we will revert back it to summation mark. Now summation mark will be we did integration and that for delta theta. So integration limit will be 0 to 2 pi. Now if I revert back it to, this is another philosophy. How I can revert back from integration to summation. We have talked about summation to integration. From integration back to summation. If I say integration back to summation, it will become I equal to summation sign I equal to 1 to n, and then it will be square root dr by d theta for the dr by d theta or delta r by delta theta I whole square plus delta r I whole square, delta r by delta theta whole square or dr by d theta whole square plus r whole square root delta theta I. Okay, means for any ith section, if I talk about the arc length for any ith section, if I talk about the arc length, then that arc length is a square root of dr by d theta whole square plus r square delta theta I. That is the arc length. Where delta, this is a very big thing we are talking, very very big thing. What is the delta theta? If I talk about the circle, if I talk about the circle, ith section we are talking. Generally, if I talk about the ith section length, and this is r, if this is r and talk about ith section length, it will be r, and this angle is delta theta I. Delta theta I is for ith section. If this is delta theta I and this is r, then this arc length will be r into delta theta I. That will be the arc length, r into delta theta I. But since radius is vary with the theta, at this point radius is different and we move delta theta, then radius will change. Radius will not be constant. In that sense, we cannot say that arc is r theta. Generally, arc is radius into theta. Whatever theta angle is, if I multiply with the radius in radian, not in degree, then arc length we will get r into theta. If theta is 2 pi and radius is constant all over, making a circle, it will be r into 2 pi, that is the circumference. If radius is varying, then what is the arc length for the ith section? That is square root dr by d theta. The way radius is varying with the theta, I have equation like r equal to cos theta. Square root dr by d theta whole square plus r square. Okay, plus r square means this is the first r. I'm not talking about this r. R square plus dr by d theta, how r is varying with the theta whole square root into delta theta I. Earlier we had delta theta I into radius. Now radius part transformed into a square root of dr by d theta whole square plus r square. Okay, or I can say Ri square. In the ith section, what is the first radius? That is the Ri. This is different. Ri whole square plus how much this radius is changing with the theta. So I can say dr by d theta at theta equal to theta I. At that time, what is the theta? If this is varying, radius is moving with the theta. When it is touching the ith section, at that moment, what is the theta? At that theta, how much the radius is changing with the theta? dr by d theta when theta is equal to theta I, not delta theta I plus ri whole square root. This replace the r. The earlier the arc was r into delta theta I was the arc of the ith section. Now arc of the ith section is a square root dr by d theta whole square, theta at theta equal to theta I plus ri whole square delta theta I. If I reverse it, from the integration to summation, then I get the arc length for the ith section. Anyway, we will proceed with this concept, what concept we have given to calculate the area of a circle where radius varies with theta. Hop, 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 hop. Okay, what is area of the circle? Area of circle is pi r square. Okay, now the circle is centered at the origin. Consider circle is not centered at the origin. This is our origin and this is the circle. We have seen many times. What is equation of the circle? Equation of the circle is r equal to cos theta, or this can be a circle like this. Okay, we're little bit shifted like this, and this what we are showing, it can be like this also. There can be many ways circle can go. Circle can go like this, and then from here it will come like this. It will make a heart shape called cardioid. How r is function of theta? If this kind of, there are innumerous way I can draw a circle. What is the area of circle where r is function over theta? If r is not function over theta, then area of circle is pi r square. If r is function over theta, then what is area of the circle? Consider circle is like this, and this is the center of the circle. This is the origin, where center of circle is here. This is the exact circle drawing for the equation r equal to cos theta. Now anyone would say, if you try to find the area of the circle, this is center, right? From center at now this is x-axis. Now radius is moving and come to a stage where angle is theta I. It makes many sections. Divide the circle into many sections and talk about the ith section. This radius and this radius. It makes the I section. What is the area of the ith section? Now add all the section, you will get the full area. But it is not that simple the way we did in the kind of circumference calculation. Delta xi plus delta y whole square root gave me the ith section arc. What is the ith section area? If this is not available in any of the book, whatever explanation they are giving, that is absurd without any reasoning. Okay, what is the area of the circle when circle is not centered at the origin? The origin is here, and this circle is drawn because radius is function of theta, r equal to cos theta. If that is the case, then what is then I take ith section. I divide the circle into many sections. I take ith section and try to find the area of the ith section. Then I add all the section and it gives the circle area. We will proceed on this. These are not available in any of the books. Someone can try. Whatever is there, it is absurd. No one can understand it. Anyway, please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.